Good evening and welcome to the Kansas City Public Library. I'm Jonathan Kemper and I'm currently serving as president of the library's Board of Trustees. In the absence of our distinguished director, Crosby Kemper, I am glad to make the introductory remarks for this evening's program. There's another reason why this event is special to me personally. I am currently serving as on the National Board of the Smithsonian, an experience that has given me both great insight and personal delight, learning how the workings of this very special 163-year-old national enterprise can and does affect our lives, our understanding, and our future. Your public library is partnering with the Linda Hall Library and the Smithsonian in a series of 5 presentations by Smithsonian institution scientists, and they are Saving North America Orchids, presented by Dennis Wiggum, which will be on June 12th, Why Healthy Forests Matter, presented by Stuart Davies on August 28th, the Panama Canal Watershed, Science, Commerce, and Sustainability, presented by Jeff Hall on September 18th, and Explore the Unexplored by Carol Baldwin on October 30th. All events will be at 6:30. The August event, Why Healthy Forests Matter, with Stuart Davies, will be here at the Plaza Library. The other events will be at the Linda Hall Library. Now, while always popular, the Smithsonian has not been content with its popular label as the nation's attic. So recently, the Smithsonian has been inserting the tagline, "Seriously amazing," to its communications, which indeed it is, seriously amazing. Today's Smithsonian comprises 19 museums and galleries, the National Zoo, and a range of research facilities. Its budget last year was $775 million, 65% of which came from federal appropriation. It has over 130 million items in its collections and 30 million visitors annually. Now, the Smithsonian was founded with a bequest from James Smithson, an English scientist who famously never visited the United States during his life. The bequest came with the purpose to create an institution in Washington, quote, I'm quoting from his bequest, to increase and diffuse knowledge. Now, as one might expect from an organization with such a diverse portfolio of activities and an aspirational mandate, trying to capture and direct its activities, mission, and goals are major challenges. 4 years ago, the Smithsonian adopted a strategic plan organized on 4 grand challenges, and they are unlocking the mysteries of the universe, understanding and sustaining a biodiverse planet, valuing world cultures, and finally, understanding the American experience. Tonight's lecture, Why Healthy Oceans Matter, would seem to fit neatly into the second box, which is labeled Understanding and Sustaining a Biodiverse Planet. But like most every important question in the Smithsonian and in science, the issues relating to this subject, the health of our oceans, have complex relationships to the sustainability of human culture globally and, of course, to the United States and its policies to remain strong and competitive in an increasingly interdependent world. And, in fact, to the physics and future of our planet as a medium for life. Dr. Nancy Knowlton is the Sant Chair for Marine Science at the Smithsonian's National Museum of Natural History and a scientific leader in the census of marine life. She wrote the book Citizens of the Sea to celebrate 10 years of the census. She founded the Center for Marine Biodiversity and Conservation at the Scripps Institute of Oceanography at the University of California, San Diego. Her research interests include marine biodiversity and conservation, ecology, evolution, behavior, and systematics of coral reef organisms. Knowlton is on the AAAS Board of Directors and was awarded the Peter Benchley Award for Science in Service of Conservation. Among the other professional activities, Knowlton is a senior scientist emeritus with the Smithsonian's Tropical Research Institute, Board of Directors for the Coral Reef Alliance, the Pew Marine Fellows Advisory Committee, and is on the editorial board for Ocean Portal. She has devoted her life to studying, celebrating, and striving to protect the multitude of life forms that call the sea home. Please join me in welcoming Nancy Knowlton to the library.
Thank you very much for coming tonight. Is the mic working okay? Yes? This is my first trip to Kansas City, and I'm afraid it's a really short one, so I got a kind of micro tour this in the middle of the day. But my father sold John Deere tractors from a panel truck, and I'm sort of channeling my father, who's sadly no longer with us, in being here and thinking about him driving around Kansas City trying to sell tractors. So I'm curious, how many of you have actually been to the Smithsonian in Washington, D.C.? Oh, lots of you. So this is practically hardly need to be here, but I hope you'll all bear with me. What I'd like to do before I start my talk, I'd like to say a few words of thanks. In particular, I'd like to thank Jonathan and Nancy Lee Kemper for making the connections between the Smithsonian and the Kansas City Public Library and making this event and the other events that were mentioned possible. We really couldn't do it without those connections and friends like the Kempers. And I'd also like to thank Henry Fortunato and the Kansas City Public Library and all the staff of the library for the help they've provided in organizing this lecture and making it possible for me to come here. And I know there are some, actually I just found out, there are lots of friends of the Smithsonian here in the audience, and so after the talk, if you'd like, please feel free to come up and introduce yourselves. And I think my introduction sort of gave you a feeling for the Smithsonian, so I won't say any more words about the Smithsonian, simply to say that what I'd like to do is give you a feeling for what I, as one member of the Smithsonian Institution, does in my daily life as a scientist and a communicator for the Smithsonian. So let's begin. First, my life as a Smithsonian Institution scientist. I'm not going to talk a lot about this really at all because it's a whole nother lecture, but I did want to mention a couple of things. You can see me here in the waters off Saudi Arabia, diving in front of this structure. We call them sort of underwater dollhouses or condominiums. We put them on coral reefs for about a year or two and then pick them up. And when you pick them up and look at them, they actually, they look like those individual plates. They look like this. And so a big part of what I do in my science career is use the marvels that have been brought to us by the genetic and genomic methods, really, and those were brought to us really by the Human Genome Project, and use those state-of-the-art genetic techniques to figure out what lives in the ocean, because in fact about 90% of everything that lives in the ocean has never been studied by a scientist, has never been given a name. And so really the best we can do in many cases is simply study the DNA from these organisms and use that DNA to figure out what's living there. So here you see a plate from one of these structures after this, I believe, was taken from a structure actually in Indonesia. And you can see it's covered with literally hundreds and hundreds of different kinds of organisms. And so we can analyze it. If we had done this with traditional methods, it would have taken maybe a decade to figure out everything that lives in just this simple structure. And now with these modern DNA methods, we can do it in a week. It's really miraculous. And so this is part of actually a big project the Smithsonian is launching called Marine Geo, or more formally, the Tenenbaum Marine Observatory Networks, where we are using these and other standardized methods in a global array around the world to figure out what lives in the ocean and how what lives in the ocean is changing across space and through time. So that's my life as a scientist. That's the sort of, Jonathan mentioned the increase in diffusion of knowledge. That's the increased side of my knowledge side of my life. And then there's also my role as a Smithsonian Institution communicator. That's the diffusion of knowledge. And that I have to say that not all scientists have that kind of, that opportunity to really talk about science to the public as I'm doing right now here in this room, as well as do scientific research. It's one of the things I love about my job at the Smithsonian is I get to do both. And so in that context, Jonathan mentioned this book I wrote, Citizens of the Sea. I encourage you all to buy a copy. Unfortunately, we don't have any here to sell, but you can buy it online. And it's actually was a real pleasure to take it was the opportunity to distill about 35 years of my thinking about the ocean into a series of about 75 or 80 short stories. There's no jargon, there's lots of science, but it's all under the radar. So you can enjoy it whether you're 5 years old or 105 years old. And it was really a pleasure to write. And it's been really a pleasure to see it sell so well, I'll be honest. It's some books you write them and they kind of disappear from the planet somehow into remainder sales within 6 months. But this is still going strong after 4 years, so happy to report. And then, again, as Jonathan mentioned, I actually lead now the Ocean Portal, which is this website you see a screenshot of here. That's the URL, ocean.si.edu. And that's been a wonderful opportunity to reach huge numbers of people. Right now, we're reaching on average about 1.5 million visitors every year, and my goal, the Ocean Hall itself in the Natural History Museum gets 5 million visitors, so my goal is to somehow get the Ocean Portal in about 10 million visitors a year. I figure if a physical site can get 5 million, then I should be able virtually to get 10 million, so that's one of the things that keeps me busy as well. And then I do TV interviews and Twitter and all that kind of stuff too. So it's a really lovely combination of doing important research and being able to talk about it in a wide variety of settings, not just with other scientists. And so I had to say that I didn't actually start off as in this mixture of scientist, science communicator. Most scientists, in fact, are trained just to be scientists. And that's changing now. Younger scientists have much more of a public persona, but certainly in my generation, we were all trained to be scientists, say in the ivory tower. And so I've actually gone quite away from the ivory tower in the course of my career. So this is how I started off as a marine scientist on the shores of Long Island Sound. I actually did little experiments when I was about, maybe not that age, but about 2 years older, about 7 or 8. I was moving snails around to see where they went. My grandparents had a house on Long Island Sound, which is where that sort of photograph painting was made. So there I started there, and then in the middle here was my science career, and then here you see me in the spread in Vanity Fair, draped with seaweed, which was actually my idea. I thought that was terrific. And so what's going on here? Why is it necessary why is it important for scientists actually to talk about what they're doing? And it's basically because of the second point here, that not only have I changed, but so has the ocean. It's changed enormously in the course of the 40 years that I have been studying it. It's literally 40 years exactly, because it was in 1974 that I first went to a coral reef. In fact, this is a picture from very shortly after that from Discovery Bay, Jamaica. And those of you who are used to seeing coral reefs can see that there's all this live coral here, big heads here, and all this branching stuff is live coral. And in fact, if you took a tape measure and measured what was on the bottom in Discovery Bay, Jamaica in the mid-70s, you'd find about 70% of the bottom was actually covered with living coral. It was like an underwater jungle. Now, we knew this wasn't an intact, perfectly pristine reef, and that you can see by what's not in this picture. What's not in this picture is much in the way of big fish. In fact, there's a small fish here that's about 3 or 4 inches, and these fish are 2 or 3 inches. They eat plankton. But almost all the fish were gone, even back in 1975. And that's because Jamaica was and is a very poor country. And even back in the mid-70s, when I first started my career as an ocean scientist, the reefs had been stripped of most of the edible things on the reefs in order to feed the families of desperately poor and hungry Jamaicans. Now, at the time, we studied these reefs, and we knew the fish weren't there, but we didn't worry about the reefs per se. In fact, we did all sorts of, we didn't think about reef conservation or ocean conservation at all. I'm not sure we ever had a real conversation about conserving coral reefs. And that's because we basically took these reefs for granted. We took them for granted because we didn't realize the connection between the healthy coral and the absence of fish. And that turned out to be a huge mistake because by 1985, those reefs had disappeared for a variety of reasons, having to do with storms and the outbreak of diseases, but in particular, the fact that with the absence of seaweed-eating fish, when these bad things happen other bad things happen to the reefs of the north coast of Jamaica, they simply weren't able to recover. They'd lost their resilience, and instead of rebounding, they collapsed. and became covered with seaweeds. And so very early on in my career, I absorbed the lesson of the fragility of nature and the fact that things can seem fine on the surface, but underneath there may be real problems, and you have to be sensitive and aware of those. Now, this is a disaster not only for the corals and other organisms that live on reefs, and this is a problem, of course, that is unfortunately not limited just to the reefs of Jamaica, but really a global problem with coral reefs. And it's not only a problem for reefs, it's a problem for people. And most reefs, in fact, line the shores of developing countries. So here you see a global map, and the lighter the color green, the poorer the country is. And as you can see, most reefs are found on the shorelines of very poor countries like Jamaica. And these poor countries depend on reefs for food, for tourism, for biodiversity in general. In fact, we all depend on reefs for biodiversity. There are important medicines that come from these hyper-diverse environments that coral reefs represent. And of course, coral reefs are actually physical walls, structures, and provide really important protection to communities living near the coast from, say, tsunami waves or the waves associated with hurricanes and typhoons. And it's estimated that globally, reefs are worth nearly $30 billion US every year. And in Hawaii, bringing it a little bit closer to home, here's an analysis of the extent to which Hawaii depends financially on coral reefs. And what's really interesting about these numbers, so the total is about 361 million from things like tourism, things that don't involve taking stuff out of the reef, and only about $3 million from fisheries. In other words, economics and economic activity that involves taking things away from the reef. And that's typical of any tourism-dominated economy. So the real value of reefs is not what you can take out of it, but what people will pay to come and visit a reef. And I'll get to that in a bit, associated with shark conservation in a few moments. And I said this was not really a problem just of Jamaican reefs, it was a global reef problem, and it's not just a reef problem, it's really a global ocean problem. And so why is that? It's because essentially we're doing this huge experiment on planet Earth, or planet ocean, if you will. And on the input side, we're putting carbon dioxide into the atmosphere, which is, of course, warming the atmosphere, therefore warming the ocean, but it's also dissolving into the ocean, making the ocean more acidic. We're putting nutrients in the water from agriculture and sewage. We're putting toxic material in the water associated with industrial activity. We're putting sediments, basically mud, into coastal marine habitats associated with deforestation and poor construction practices. And we're moving invasive species from place to place across the ocean through our shipping and aquaculture and aquaria. And then that's the input side. On the output side, we're essentially taking out everything big. Not only all the big fish, it's been estimated that about 90% of the fish have been removed, but also sometimes we even use corals and other large marine organisms for construction and other purposes. So this is a huge, giant experiment we're doing on planet ocean, so it's perhaps not too surprising that there are so many problems. And here's a few of them. First is collapsing fisheries. This is a map that shows the biomass, that is the weight of edible fish in 1900, and the red color shows parts of the globe for the North Atlantic where there were more than 11 tons per square kilometer. That's what it looked like in 1900. That's what it looked in 2000. So there's a huge, huge collapse in fisheries that you can see from these data. Similarly, harvesting of oyster reefs has resulted in an estimated loss of about 85% of all the oyster reefs. And this photograph gives you a sense of why there are so few oyster reefs left. This is a person standing in these piles and piles of harvested oysters, so massive overexploitation of oysters. Only about 16% of ocean habitats are unaffected by invasive species, and here you see two. This is a lionfish. It belongs in the Indo-West Pacific. It has invaded the entire Caribbean and is eating up what few baby fish remain on Caribbean reefs. And here you see a seaweed which is spreading across the entire Mediterranean Sea, covering the natural seagrass communities, reducing diversity and the productivity of the Mediterranean. And then here we see a map of dead zones. And I'm pointing to one in particular because somebody said, I think it was Jonathan said to me when we were talking before the talk, he said, you know, we're a long way from the ocean. I said, actually, you're really close to the ocean here in Kansas City because you're directly connected to the ocean, that is the Gulf of Mexico, thanks to the Mississippi River watershed. And this huge dead zone that occupies the Gulf of Mexico, which I'm sure most of you have heard about, is a direct result of nutrient pollution in the entire Mississippi River watershed. And it's been estimated recently that pollution cost about $82 million in terms of lower shrimp catches and also reduced income from charter fishing trips every year. And of course, it's not just the Gulf of Mexico. You see these dead zones wherever there are large populations around the world. And when I first started using this slide, there were only 150 globally, and then the most recent update was there are now 400. And then finally, I want to share this picture with you. It was taken during a trip I made at the invitation of the State Department. I went to the Philippines to talk about coral reefs during the celebration of something called the Coral Triangle Initiative, because the Philippines is in one of the places of the ocean which is the most diverse of anywhere on the planet. But you'd never guess that from this picture where they took me diving. And here you see a reef in the Philippines, and it's almost all covered with seaweed. All this brownish, greenish stuff, that's all seaweed. There are a few pieces of live coral here, but most of them are white, and they're white because they've bleached. That is, the warm water associated with global warming has caused a breakdown in the relationship between the coral and the algae that live in their tissues. And so most of the corals, the few corals that survive, are actually also dying. And what was really striking about this dive that I made is the first time I've ever been diving where I spent 45 minutes underwater and I didn't see a single fish. And in the end, this is an issue. I've talked a little bit very briefly about what intact coral reefs are worth, what the costs of polluting the Gulf of Mexico are. But in the final analysis, this is, of course, an issue of food security. After that dive, we were sitting on the beach. We actually had a drink because we were so depressed about the condition of the reefs. And we were sitting on the beach, and this fisherman arrived and started throwing his net. So here's a fisherman. Here you see his net. And I looked at my host, and I said, what can this person possibly be catching? We just spent 45 minutes in the water. I literally didn't see a single fish. And he said that people had done studies of the economics of fishing in that region, and that person could expect to work for an entire hour, and the total catch would have a caloric value of a can of Coca-Cola. So for countries that really depend on the sea for food, which is a large number of countries and a large number of poor countries, this is an issue of people actually not being able to feed their families. And so perhaps it's not too surprising that even marine conservation professionals like me and other people who work in this field can get a little depressed. And I went to a meeting of the International Marine Conservation Congress a couple of years ago, and I created this Wordle from all the abstracts that were submitted as contributions for this conference. And this is the Wordle. For those of you who've never done a Wordle or a word cloud, it's basically just the most common words in those texts that I imported, and their commonness is related to the size in the Wordle. So you see all these words that make sense: conservation, marine management, fish, protected fisheries data areas, etc. But what really struck me about this word cloud or Wordle were the words that weren't in it. Where were the words like recovery or success or benefit, improved, anything positive about the ocean? This was a marine conservation congress. This was not a collection of people that are supposed to be just bemoaning the state of the ocean. And yet those words were absent. In fact, the only positive word I could find in the entire thing was circled here, and that's the very small word, effective. And for all I know, in the abstract, it might have said not effective, but there it is. And so it was for reasons like that that I started this project called beyond the obituaries. As Jonathan mentioned, I created something called the Center for Marine Biodiversity and Conservation at the Scripps Institution of Oceanography. And this was a program to train students to work in the field of marine conservation. And we started the program every summer with a 10-week course to get all the students. Some of them were actually from economics or conservation, biology, physics, a very diverse group of students. So we gave them lectures for 10 weeks to get them all sort of on the same page with respect to ocean conservation. And we would stand up there at the beginning of the 10-week course and we'd tell them a longer version of what I've just been talking to you about, all the horrible things that have been happening to the ocean over the last century around the world. And I could physically see them all sinking in their seats, kind of physically and mentally, and I'm sure some of them were wondering why in the world they ever signed up for this career anyway, because it was so depressing. And I started thinking about what we were doing. We were really trying to train essentially doctors of the planet. These are environmental scientists being trained to solve problems. In that sense, they were very much like medical doctors, the only difference being instead of their patients being people, the patient was the planet. And I thought, well, you know, in medical school, we don't train our students to write ever more refined obituaries of nature. We don't train our medical students to write ever more refined obituaries of their patients, but that's what we were doing in this program. We were training our students to write and document the death of nature, ever more refined obituaries of nature. And I said, this cannot be the best way to train conservation scientists. And so that led me to create this program called Beyond the Obituaries. And you see here a clip from the Ocean Portal, which is an example of a story. And the essence of it is twofold. One is to talk about success, and then also talk about stories of success. So why success? Well, the problem with only talking about doom and gloom when it comes to ocean conservation is it's not a very motivating message. People get so discouraged they feel they can't do anything and they tune out and go to the bar or whatever it is they do to forget about their problems. And so this is this wonderful cartoon from the New Yorker, making a difference doesn't make a difference. And that is the problem we face in conservation. All this unrelenting bad news has caused the public to really assume that there's nothing they can do, and if there's nothing they can do, there's really no point in worrying about it. So it's really important to talk about successes. But equally important, it's important to put those successes in the context of stories, because people relate to stories. They remember stories. They are motivated by stories. And in fact, the entertainment world and the business world know this very clearly. So if you go on Amazon.com and Google and search for storytelling, you find books like this, The Storytelling Animal, How Stories Make Us Human, or this one, which is more of a business book, Lead with a Story. Unfortunately, scientists tend to say something like, I'll pause for a moment so you can let this information sink in. They tend to lead with the data and not with the story. And so the story part of it is least as important, I think, as the success part. And in fact, I've been collaborating with a PhD scientist turned Hollywood filmmaker, and he's written 2 books, one called Don't Be Such a Scientist. Any of you who are in science communication or science in general, I urge you to read this book. It's a very funny take on why scientists could be much better communicators than they are. And then more recently, a book called Connection, Hollywood Storytelling Meets Critical Thinking. And we collaborate a lot in terms of trying to tell conservation stories in a way that are appealing. And what's important about this, particularly in the context of conservation, is that every single conservation success has a story. There's always a hero that saw things were the way they shouldn't be and wouldn't take no for an answer, but had to struggle against odds, finally succeeded, and then there's the success at the end. There's a natural narrative arc in almost every single conservation success we have, and it's ridiculous not to take advantage of that. And so what I've been doing for the last couple of years in my Smithsonian communication role is to collect these examples of successes in ocean conservation as part of this Beyond the Obituaries project. And it turns out there are a lot more successes than people ever realize. The first time I ran a conference on success stories in ocean conservation. I had a whole day at the Smithsonian before the beginning of one of these conservation congresses. And I remember talking to a colleague, and the person said to me, Nancy, you can't have a whole day of success stories. there aren't that many success stories out there. And it turned out there were so many success stories. I got about 100 submissions so it was sort of like speed dating, and everyone only had 5 minutes to talk about their successes. And they were just kind of yanked across the stage. So there were actually lots and lots of success stories. It's just that we had this tendency to focus on bad news and forget about the achievements we've actually accomplished. And so I've sort of started organizing these successes, and they fall into 5 basic categories. One is saving species. That's success that's focused around particular species. Protecting spaces, particular places in the environment. Is that me doing that? I don't know what's making that noise. Something happened here. Harvesting wisely, that is using the resources that the ocean provides, but doing it in a way that it's sustainable. Reducing pollution, and then finally restoring habitats which have been damaged, like the ones that I've shown you pictures of. Thank you. There you go, minor adjustment. So there's not time to give you these hundreds and hundreds of successes, so what I'd like to do is share just one example of each of these kinds. So the first comes to me from a colleague of mine at Simon Fraser University in Canada, and he teaches a course in conservation biology. And he told the story, and again, note the story, told the story of this student in his class named Claudia Lee, who you see here. Now, she's a Chinese Canadian, and she wasn't actually a biology student at all. She was a business student. And she had for a long time been very resistant to the idea that Chinese cultural tradition of serving shark fin soup was contributing to the decline of sharks worldwide. She thought it was an attack on Chinese culture. But for one reason or another, she wound up watching this movie about shark finning and was so horrified, she realized she had to do something about it. And so she started this NGO called Shark Truth, which you see here. And being a good business student, rather than a biologist, she had a business plan, and she thought about what is the most strategic point where I can address this problem most cost effectively. She realized a huge amount of shark fins were served at wedding banquets. So she organized a competition where couples would pledge not to serve shark fin soup at their weddings. And she's estimated as a consequence of this activity, she's saved about 1,800 sharks, because every wedding table essentially translates into one dead shark. And what's really interesting about this effort is on the one hand, it's a small effort. 1,800 sharks, not a lot of sharks compared to the millions that we're killing every year. But it's an effort. It's efforts like this that are popping up everywhere around the planet. And so around the world, there are shark finning and fin sale bans being established or promoted for Central America, the European Union, Palau, a number of states in the United States, and particularly important, the Peninsula hotels and the Chinese government have now banned or are about to implement bans on serving shark fin soup. And so this is really starting to have traction and really beginning to spread. And why is this happening? Well, in some cases, it's because people feel really badly about sharks and they feel some moral issue not to kill sharks and cause their extinction. But it's also, particularly in the case where governments take action, is because of the simple economics that live sharks are worth a lot more than dead sharks. Because people spend fortunes to go to places to swim with sharks, and it's a gift that keeps giving. And so many countries have now realized that it's crazy economically to allow the harvest of sharks because they're undercutting their tourism industry. Now, the second story, this is about protecting a place, comes from Mexico, but in a place called Cabo Pulmo. And this is a small village, basically an extended family, and the senior member of the family, the paterfamilias, if you will, watched over time the amount of fish that his family and friends were able to collect decline. He'd have scientists come and tell him that things were only going to get worse. Tourists would come to him and say that there was nothing interesting to see in the water. And so he decided that the current trajectory that they were on at that time was simply completely unsustainable. He got his friends and family together. They set up a marine protected area in Cabo Pulmo and has now been described as the most successful marine protected area on the planet. So here you see the results of that effort. This is 1999 to 2009. These are places that aren't protected at all. No change also in places protected by the government. But here's the Cabo Pulmo marine protected area. You can go online and see amazing pictures of the fish, schools of fish that are found here. And what's particularly interesting about this story, and again, you have, of course, a really clear hero in this story, the person who realized that there was a better way to manage things. It's not just the fish that are doing better, it's also the people are doing better, because the tourism associated with this success is resulting in about $18,000 more income per year per capita, which is a really huge increase for that part of the world. Here's an example about harvesting wisely. It comes from Chile, where the fishery has focused on this small snail. It's often called the Chilean abalone, although it's actually not an abalone. And it's a very highly prized delicacy, and for a long time it was so overfished that you could scarcely find a single one of these Chilean abalones anywhere in the water. And here you see a map now of what's happening with conservation in Chile, and these all these red spots, which you can see as most of what's happening in terms of conservation, represent what are called territorial user rights for fishers, or TERFs. These are communities of fishermen getting together to decide what is the sustainable level of harvesting, and because they control the resource, keeping to that level. And again, just as in Cabo Pulmo, here is open access where there are no rules. These are no-take marine protected areas, which actually are well enforced. But look at this. These are places where fishing is allowed, and yet the number of these abalones are just as high as they are in no-take areas. And so, again, this is an example where not only are the organisms doing better, but so are the people that depend on them. In terms of reducing pollution, I like to actually mention this story because it's a classic example of how we forget how much we've achieved. Where I spend the summers now in Maine, there are ospreys everywhere. There are so many ospreys you hardly pay any attention to them at all. But not that long ago, ospreys were on the verge of extinction due to pollution from DDT, which was thinning their eggshells. And so with the writing of Silent Spring by Rachel Carson, who really started an environmental revolution in the United States, DDT was eventually banned in 1972. And here you see just one example of the number of osprey nests in one part of the east coast of the United States. And this is an example that we now, when we see ospreys, we take them for granted, and we forget that it was through our actions that ospreys were saved. And similar kinds of stories can be told about a lot of historic conservation successes, which we now take for granted and forget to congratulate ourselves on. Here's finally an example for habitat restoration. It's based on the work of a scientist at the Virginia Institute of Marine Science. And what had been going on in the Chesapeake Bay, because of all the oysters being removed, is that people were trying to restore them, but they'd scatter a few oysters here and there, and then they'd all get buried by mud and die. And so the scientists realized that the methods that people were actually spending millions of dollars trying to implement were simply not working. And he set out a number of experiments to say, okay, what's necessary to restore an oyster bed? And it turns out you just have to do it big enough. You can't scatter a few oysters. You've got to make a big pile of them. But if you make a big pile of them, then they grow much, much faster than if you have a small pile. And so this is now the basis. This new method is now the basis of extensive restoration of oyster beds up and down the East Coast. So those are some examples of marine conservation successes. I'd like to conclude with a few final comments about other aspects of marine conservation that I think are important to consider. And one is the special power of art and community. And what you see here is an exhibit from the Natural History Museum, which I helped bring. It was called the Hyperbolic Crochet Coral Reef, and it was the brainchild of two twin sisters in Los Angeles who realized that this crazy form of obscure geometry was translatable into crochet and knitting, and when you did that, the things that were crocheted or knitted looked like coral reef organisms. And so they were from Australia, they loved the Great Barrier Reef, and they started this project called the Hyperbolic Crochet Coral Reef. And it spread has spread like wildfire throughout the entire world. There are crochet coral reefs in a variety of different places. In fact, this particular reef traveled to Davenport, Iowa, not too far from here. And what was amazing about it was the way it linked science, conservation, mathematics, and community and art. The structure was about the size of the footprint was about the size of the stage, and it was actually not that much shorter than the height of this stage. So it was a huge structure. It was made of about 4,000 individual pieces of crochet created by about 700 different contributors to the project. And the sense of community and engagement that was generated in this group of people who would normally not necessarily be that interested in marine conservation was extraordinary. It was one of the most successful exhibits we've ever had at the Natural History Museum. And what's particularly interesting is the fact that it brought so many different communities together. In fact, we got a lot of press for this exhibit. The press I am most proud of appeared in a magazine called Street Sense, which is a magazine by and for homeless people in Washington, D.C. And the front cover one week said, "Homeless women stitch their way into the Smithsonian." So I'd like to conclude to say that these examples that I've been giving you, a lot of them involve single individuals really trying to make a difference. And some of them are illustrated here, and some of them I haven't had the time to tell you the stories of. These are all people working in science and conservation or the arts who are really working to make a difference and have made a difference. And I often get asked at the end of talks, what can I do? And how can I possibly do anything, because the ocean is so big and the problems are so big. And I now routinely answer with this wonderful African proverb, which reads, "If you think you're too small to make a difference, you haven't spent the night with a mosquito." And so I'm sure you have plenty of mosquitoes here. So it gives you a sense, and there's a real truth to this. And essentially all of these conservation success stories that I've talked about, and the ones that I haven't had a chance to talk to about, are basically individual mosquitoes working to make a difference. And here in Kansas City, there's a ton of stuff I'm sure you're already doing, and a ton of stuff that you could do. I mean, when I think about Kansas City, I think about the connection to the Gulf of Mexico and the fact that essentially everything that goes down the drain here winds up in the ocean one way or another. So there are all sorts of possibilities with looking at water quality, reusing bags rather than using plastic bags, using reusable bags. There's all sorts of ways of reducing the impact of your neighbor, the Gulf of Mexico. It may seem far away, but it's your neighbor, and reducing the impact of your activities on a very important body of water for the United States. And so to summarize, we need a combination of these local activities, and in fact, we actually know what we need to do in terms of keeping a healthy ocean. And essentially, we need to control fishing pressure and improve water quality. This is not rocket science. What's hard is the actual gathering of the political will to take these steps, but the science is pretty well settled. And this is very important on the short term and the local scale, because what this does is create healthy ecosystems that are better able to withstand the changes that are being caused on a global scale and over a longer term associated with carbon dioxide emissions. Now, I don't want to minimize climate change, because climate change is the huge elephant in the room, and eventually the effects of climate change will swamp the system. And sometimes it's so depressing to think about climate change, because it seems like progress is so slow, and maybe it won't happen at all, and what can we possibly do? And it's a very disengaging way of thinking about ocean conservation. And sometimes people we've even had papers rejected saying, you can't possibly worry, it's all hopeless, don't worry about it, just give up because climate change is insoluble. And I think that's a crazy way of thinking. And in particular, it's really important to remember this short-term local scale. There's a lot that we can do right now to make a difference. If the reefs in Discovery Bay, Jamaica, had been managed properly in terms of fisheries, they wouldn't have collapsed, even with current levels of climate change. And so it's essential to remember this while continuing to work on this. And I'd like to show you, I went to that horrible place in the Philippines in June of 2013, but in November of 2013, I went to this amazing place in the middle of the Pacific Ocean called the Southern Line Islands. And these are places that are so far away that there's no fishing, there are no people at all, and they give you a window on what a healthy ecosystem, a healthy ocean looks like. So here you see a coral reef. Now this is not a coral reef protected from climate change or ocean acidification, because those are global things. So it's still suffering from warming, and it's still suffering from changing ocean chemistry. But look at this reef. There's coral, living coral is everywhere. The water is full of sharks and snappers, and for that matter, manta rays and turtles. It's an extraordinarily healthy, vibrant reef. And what this tells you is that a healthy ocean buys time. And so when I ask the question, why a healthy ocean matters, this is perhaps the most important answer. It will buy us time while we try to figure out how to deal with climate change. And so I'd like to conclude with this slide. I was, before I came, I've been away in Europe for about a month, and at the beginning of May I went to a meeting that was organized by the Pontifical Academy of Sciences and the Pontifical Academy of Social Sciences. And we gathered together as biologists and climate scientists and economists and historians to talk about sustainability. And this was an effort organized by the Vatican. And at the end of the meeting, we actually were incredibly honored to be introduced to the Pope. And it was an extraordinarily moving experience for me. I'm not Catholic, so it's not a kind of narrowly religious experience. It was an experience of looking at a person who, again, is not willing to take no for an answer. And then about 2 weeks after our meeting, he was giving the Wednesday address, and this is what he said in translation: safeguard creation, because if we destroy creation, creation will destroy us. Now, scientists have been saying this for a long time, but here it is in the words of a religious leader as well. And so I think there's enormous hope in the possibility of different communities of people, homeless people, religious people, scientists, journalists, people like that I talk to on a day-to-day basis in all sorts of different careers and walks of life. If we really work together, we actually do have within our grasp the possibility of a healthy ocean, not just for ourselves, but also for our children and our grandchildren. Thank you very much.
Nancy, we'll take a few questions up here at the two microphones if you guys want to line up in the aisles. Nancy, maybe about 5 minutes, 10 minutes of questions.
I have two questions. First question is, as early as 1963, it was reported that Maryland shore was gradually sinking. So you have an update on that. And my second question is, as a scientist, do you have a timeline if our oceans continue on its present course with countries like Iceland, Norway, Japan? How will that affect their fishing industry?
Okay, so the question about the sinking of the Maryland shoreline, I don't have anything super up to date. That's a bit out of my general expertise, but it's certainly the case that there are places that are sinking, including places on the east coast of the United States, and also, of course, the Louisiana coastline is also sinking. And in those places, people, I'm sure you've all read about sea level rise. In places that are also sinking, obviously, it aggravates the problem of sea level rise because the effect of sea level rise is faster if not only is the water going up, but the land is going down. So it's in general true that that portion of the east coast of the United States is sinking, but I don't have the exact rate for you that I can just give you off the top of my head. In terms of fisheries, it's been estimated that about 90% of all the large fish have already been harvested from the ocean. And what we've been doing, as you saw in those graphics that I showed you, is simply moving farther and farther away, including, for example, the coasts of developing countries like Western Africa. And so what we seem to have when we go to the fish market, a never-ending supply of fish, but that's partly because we're going farther spatially and also deeper. And so we are eventually, in fact, already getting to the point where the amount of fish that we can pull from the ocean is essentially reached its peak and is now declining. It's been partially rectified by aquaculture, although in many cases for aquaculture we have to harvest fish in order to feed them. That said, there are, as in all these other examples, there are places where fisheries are being well managed and managed sustainably. We know how to manage fisheries sustainably in many cases. The problem is more the political conflicts that arise when we try to make the decision about how to do it.
Thank you. I have two questions, basically, which are kind of related. We get kind of mixed messages about the safety of fish, mercury, toxic substances. But we also get the message that omega-3 is really great for us. What is your take on the safety of farm-raised fish? That's question one. And question two, how do you feel about the destruction of dams to restore fish runs like on the Oregon coast?
I'll answer the second question first, which is that the destruction of dams seems to be making a big difference in terms of the restoration of historic fisheries runs. And those, to my knowledge, have been very successful in our efforts that are spreading. In terms of the health of fish, both wild-caught fish and aquaculture, in general, the higher the fish is up in the food chain, in other words, apex predators, tend to accumulate toxins through the food chain. So the things that are the fish that eat fish tend to have a higher load of toxins than the fish that eat plants. Now, there are some kinds of seafood poisoning that don't follow that rule, but in terms of mercury, that's definitely what's going on. And so, by and large, the more you're eating high in the food chain in terms of your fish consumption, the higher the toxic concentration of things like mercury is. And in fact, in the United States, it's recommended that pregnant women not eat a lot of tuna fish and salmon as a function of the contamination. So I think there's also no question that certain aspects of fish oils are in fact good for you. So, but there are other ways of getting some of those fish oils without eating things that are at the top of the food chain. It's hard to give a complete generic question. A lot of it depends on specific fish in a specific setting. There's been a lot of bad press about aquaculture, but aquaculture methods are actually improving. And so what used to be the case in terms of a bad story about aquaculture is not necessarily the case in all the aquaculture efforts that are ongoing now. So there have been a lot of improvements to when the initial reports were first published. Oh, sorry.
Yeah.
Okay. Oh, go ahead.
First question, a biographical question about you. I take it Rachel Carson was influential to you as a kid. How about Cousteau? Were they the two maybe, sort of public people who influenced you the most to do what you do?
Well, in a way, some of those influences are almost retrospective. I remember it, but because I wasn't focused on I was a little too young to really appreciate what they were doing. I was still sort of a teenager. I remember reading the books. I remember watching Cousteau on television, right, for sure. But a lot of what I do now, I've kind of looped back to Cousteau and Carson for inspiration rather than having it kind of guide me along the way. I think a lot of careers are like that. You don't necessarily wind up doing what you it's hard to predict where you're going to wind up from where you start because a lot of different things happen. So that's sort of the answer.
The second question is, how are the horseshoe crabs doing in the Chesapeake Bay? Horseshoe crabs, how are they doing in the Chesapeake Bay and so forth?
Yeah,
are they improving at all?
I'm not sure if they're certainly under enormous stress. When I was little, this is one of these, this is a phenomenon called shifting baselines, because what it means is that you tend to assume that what things were like when you were a kid was normal. And then the problem with shifting baseline is each generation accepts a worse environment as normal because that's what they had as kids. But when I was a kid, there were horseshoe crabs everywhere, all over the beach in Long Island Sound. I remember watching them mating. There were baby ones. We used to pick up the shells of them all over the sand. And now I haven't seen a horseshoe crab in I don't know how long.
Right.
They're harvested. They're affected by pollution, and I don't remember reading any reports saying that they're rapidly recovering, but you know, they're certainly not rapidly recovering. Whether you can see a glimmer of hope in their population numbers right now, I don't feel. I don't have the latest information, so I can't really tell you.
Thank you.
Yes.
Given that we're now approaching the end of our second full month at or above 400 parts per million atmospheric CO2, I thought this would be an appropriate moment to ask, just for kind of a thumbnail sketch of acidification, how it works, what you think the effects will be, how it may vary from region to region, from ocean to ocean. I guess just sort of a short explanation of what we need to be thinking about in that realm.
So
Thank you.
The interesting, ocean acidification has not been studied that long. People have been worried about climate change for a long time. Plus, there's a long tradition in physiology of studying the effects of temperature on organisms. And so, in a sense, as a scientific community, we were prepared to think about what the impacts of climate change might be on organisms. But ocean acidification is not something anyone worried about because it never crossed anyone's mind that we could actually change the chemistry of the ocean, because it's always been described as so big and so well buffered that you couldn't change something like pH. And that turned out to be wrong because of the huge amount of carbon dioxide that's in the atmosphere, and then part of it dissolves in the ocean. It's been estimated that about a third of all the carbon dioxide that's released gets absorbed by the ocean, which helps global warming but doesn't help in terms of the changing chemistry of the ocean. The effects of the chemistry of ocean acidification are very straightforward. Unlike climate change, where, I mean, the overall understanding of the effects of carbon dioxide on warming are pretty well understood, but there is a lot of detail associated with soot in the atmosphere and clouds and radiation from ice-free water and stuff that makes the details of the predictions a little bit trickier. Ocean acidification is much more straightforward in terms of the physics and the chemistry, but the biology, because no one's ever really studied it until relatively recently, is much less well understood than the effects of warm temperature. It seems quite clear that organisms that use bony material, calcium carbonate, to build shells, in general, have a harder time doing so when the water is more acidic. And for example, there are some very interesting places in the ocean where carbon dioxide bubbles up naturally from the bottom. And so you have a kind of window into the future sitting there right in front of you. And if you, for example, look at such a place in Papua New Guinea where coral reefs live, by the time you get to fairly acidic water, there's no living coral growing near those seeps at all. And similarly in Italy, where a comparable carbon dioxide seep exists, you start losing all the snails and other things that use calcium carbonate to build their shells. That said, there's a lot of variation, even within corals. I mean, corals in general are hurt by ocean acidification, but some of them are very sensitive. They lose their skeletons completely, and others are able to tolerate a fair amount of acidification without apparent ill effects. Now, what I think what they're probably doing is spending energy to resist the effects of acidification. So even though they keep their shells, they may have less energy to do other things. But there's no question that ocean acidification is going to wreak havoc ultimately if it continues on this trajectory with a lot of marine organisms. The details of which ones will be most affected and which ones will be less affected are still being worked on by scientists.
Dr. Knowlton, thank you for bringing this very informative and positive program to us here in Kansas City. I am interested in purchasing your book and also in looking at the references you referred to in your program, but because I was listening to your words, I've completely forgotten them. Would it be possible for you to leave the information with our library so that I can access it?
Yeah, the work that I've been doing on collecting success stories is actually a work in progress. So what I would recommend doing is simply going to the Beyond the Obituaries section of the Ocean Portal. And we have a grant actually from the State Department, and part of that is going to be used to start uploading more stories of success. So within about 6 months, I'm hoping to have a lot of these stories of success. Some of them are already up there, including some I didn't even talk about. But that would probably be the best place to find it for now.
There are lots of benefits of individuals making efforts to protect and make sure there are no overfishing in their communities, but is there much importance to the government emphasizing protecting the ocean?
Yeah, I think it's really important, to recognize that you need both approaches. I mean, usually the government acts after individuals start caring. So even when we think about the government being a top-down structure, but actually it really isn't a top-down structure. It's a bottom-up structure that has then been sort of translated to a governmental top-down structure. Some of these things require government action or are greatly helped by government action. For example, there's a huge problem with what's called illegal and unreported fishing efforts by basically pirate fish. And those are, and governments can do things like prevent the sale of undocumented fish catches in their ports and really reduce the problem of illegal fishing. And government treaties can help in various ways. And governments can provide both positive incentives, for example, in terms of energy conservation, and also negative incentives in terms of wasteful energy use or carbon pollution. So there's a lot that governments can do. But the governments won't do anything unless citizens demand it. And so I think it's very important not to take responsibility as individuals, which can include working for government objectives that you might have in mind. But it's definitely a two-way street. I tend to talk about individuals in part because as a member of the scientific staff of the Smithsonian, we're part of the U.S. government. We're not really supposed to say the government should do this and the government should do this. Really not what we're allowed to do. It's by law, essentially. So just as a part of my job, it's much easier for me to talk about bottom-up initiatives. But there are also lots of NGOs that work very heavily on the government side of things. I was just on a conference call for an hour this afternoon, and one of the participants was the guy who runs the Pew Charitable Trust Ocean Program. And their NGO is totally focused on getting changes in governance in the United States and internationally to promote sustainable fisheries and a better climate future. So there are lots of, depending on where your interests lie, you can work on the bottom up, top down, or anywhere in between.
Thank you.
Yeah.
Thank you for coming. I've got one question and one thing I want to plug. The question is, you touched mostly on the toxins and stuff. You said briefly about the CO2. Can you tell us a little bit more about the impact of the greenhouse gases on the oceans versus the toxins, including, I just saw an article this week, most of what we hear about greenhouse gas is CO2 and methane. And this article was about, I forget the name of it, but there's a third greenhouse gas, which it says third most common in the world, that is increasing rapidly in China. And so I don't know if you're familiar with that, if you can comment on that too. And then the plug is, I'm a programmer over at KKFI Radio, and if people aren't familiar with KKFI, it's a community radio station. From 6 to 7 p.m. every Monday, we have Eco Radio, which is all environmental issues entirely. And if you're interested in learning about the environment, and we do have some call-in shows and national experts and stuff, It's on 90.1 FM or kkfi.org. We do live stream too.
Well, thank you for that plug, and I hope you can get some people to tell success stories on your radio show, because I think people need to hear about things that are working. About the different greenhouse gases, there are a number of different greenhouse gases, and they vary in terms of, first of all, their abundance in the atmosphere. Obviously, the more abundant ones can have a potentially bigger effect than the rare ones, but also their potency as greenhouse gases. For example, methane is a much more potent greenhouse gas than carbon dioxide, but fortunately it's much less abundant in the atmosphere. And then the third thing that people worry about is what's often called the half-life, how long those greenhouse gases stay in the atmosphere. One of the big problems with carbon dioxide is it actually stays in the atmosphere for centuries, whereas some of them are gone very quickly. And in fact, one of my colleagues, my former colleagues from the Scripps Institution of Oceanography, works on some of the greenhouse gases that are associated with cooking stoves in India. And those actually are not necessarily as powerful as and abundant as carbon dioxide, but they're things that you can actually get rid of, and then once you, in terms of their source, and then once you get rid of them, they actually disappear in a couple of weeks. So those are the three elements that are important. I think you certainly have to worry about carbon dioxide, but there are other greenhouse gases that are either can be tackled right now, which don't have the political complexity of carbon dioxide, or that need to be tackled because they're even though they're scarcer in the atmosphere, they're much more potent. So I think people who work on climate, in aggregate, climate scientists are working on all those different greenhouse gases.
Perhaps we can have your question afterwards. I just want to give one quick round of applause to Dr. Knowlton again. Thank you. Again, the Smithsonian series will continue. You'll want to check our calendar for upcoming event dates. The next one will be at the Linder Hall Library. Thanks.